Hello everybody, welcome to another stream. How are we all doing? So, last stream, we got this shader up and running for the first LOD. So we run this, so we need to call basically 7 more dispatches on it. And then and then we can move on to the next shader. So it just constructs the initial tree, but it doesn't construct it constructs the initial tree of clusters, but it doesn't construct any lower LOD spheres in the tree, and it doesn't simplify. So it's just the first sort of pass, basically. But we tested the first LOD and it does work. So what we need to do is essentially bump up the LODs. So we're going to say this volume that we're building has, we're going to draw an ellipse down at LOD1, and we're going to update the target LOD and test going down 2 levels now, right? Yeah, so this is like the dispatch code, basically. We take the volume and we go over as many LODs as it has, and we'll dispatch and create these this octree of 2x2x2 spheres inside of a cluster, right? It's just a tree of clusters and spheres. So hopefully this next one runs. So we've got to run in once. We now need to run it a second time. So we're going to put some printing code just to verify this all works, right? So what I want to do is probably just comment out these guys and put more of a so here I want to say that we're doing, so I want to print out like the node number, and we'll just say dot is outside shape or whatever. Yeah, we'll just do that, colon. See, it's outside means it's gonna skip, isn't it? And there's a spheres count at the bottom. Maybe we comment out this guy as well. This is if we're adding a sphere. Right. So this one put a node index in. Let's get that node index. Cluster node index, perfect. There's a signed valley. And also, it would kind of be nice to know, how did we get to this? Did we traverse down to get to this node, basically? So at the start, we traverse down from the top of the tree, and we go down the octree and find the correct node at certain LOD. So I just got to go ahead and put that in here, probably. So we want to basically do D to D, not that. So we've gone from cluster node to child node. Okay, so this printing information, we should be able to verify that at least some tree is being built. and whether or not it has spheres at that node, right? Um, so can I go back to the thing we're drawing down and just have a look? So we're putting something down in the middle of the volume. It's 40. It's 40 radius, and we're at LOD 1 right now. Okay, that's cool. Hey, not so red. Yeah, man, doing good. How am I doing? Not doing bad. Doing bad. I also have a Diet Pepsi today. Not my drink of choice. Oh. But it was free, so all good. But yeah, just doing good. Had a pretty chill day yesterday. Just went out and preparing for the holiday. Got some suitcases. So me and my son have a matching suitcase now. And yeah, what else did I do? Oh yeah, then we went for some meal in the evening at some like fancy restaurant basically because had some voucher for that. That's pretty cool. Got like a 10-ounce steak. And I had some I obviously had chips with it and some good garlic mushrooms. So it was pretty nice. Love me some garlic mushrooms. How's the little guy? He is 5.5 months now. So he's just about sitting up basically. So it's pretty cool. Yeah, it's gonna be awesome. So I'm gonna be away the whole of February. Literally the whole of February I'm not here. No, not teaching him C just yet. Nearly. Just 10 more times his life and we'll be, or 12 more times his life. Yeah, you're right. 5 years, no. uh, can I show results right now? Yeah, so on this whole sort of like endeavor that we're doing, where we're doing this LOD and cluster thing, we're not getting anything rendering just yet. We could probably choose to try and render what we have, but I want to bring it through the whole system and then first, because it'll just be quicker that way. But we're basically getting the first bit of it working, where it's actually putting the spheres into the clusters. I do have a previous renderer, which wasn't a whole LOD cluster thing, but yeah, effectively we've got yeah, we're just building like these guys, 2 by 2 by 2 by 2 of clusters, of spheres in a cluster. That's L0. Only has one cluster that covers a whole. Yeah. Anyway, and then this one breaks into eight clusters, each with their own 8 children, and so on. Right. So this is the thing we're sort of building right now, and 256 cubed volume. But I can show you the old renderer. So we're going to try and run this. If the stream goes down, I'll be right back. You know the drill. But this will bring up the old renderer as well. Here we go. All right, so apparently running 2 of them now. Excellent. And we're in the printing. So this is the old renderer. Obviously the colors are sort of like a local space normal. But yeah, this is when we got the model instances working, and then I realized that it was probably a good idea just to sort of redesign the whole renderer all in one go, rather than do one thing at a time. So Pretty sweet though. So I'm hoping to be able to get different sized balls with this new renderer and them to go proper tiny and have many of them, many instances, and eventually build our own like editor and stuff like this. We've got 3 different renderers running at the same time actually. We've got one which is tile-based binning, it's a ray tracer. Oh no, wait, I've disabled. Okay, maybe not. I've only got one running at the moment. There's different strategies I was running, deciding on how to bin these, how to ray trace these spheres better. Do I bin them into screen tiles, frustum, voxels, or using a BVH? And it turns out the screen space tiles was the best. I wasn't quite able to test the frustum voxels well enough because I didn't have a big scene. But the BVH seems to be a good data structure in general, but it's not as optimized for the sort of initial rays that you fire out from the screen. So if you have a ray that's just randomly in the world somewhere, BVH is a good data structure. Balls, that's damn straight. So it's going to be a ball renderer. It's going to be cool because I definitely have seen some rendering technology with spheres, right, and tons of them, but I didn't see it enough. So I think it should be pretty distinct, especially as a game. Um, does Linux allow GP driver to control when the frame is presented, etc.? Yeah, I'm on Linux. Um, control when the frame is presented. I'm not sure what you mean. Ooh. Like you call a function in Vulkan to say, uh, queue a present right after all this work has done. But you can't do it like as soon as that function is called. Not sure what you mean. Yeah, put it another way. That's probably a good idea. Yeah. Right, so we're getting these okay, so it isn't really working as well as I hoped. Um this is not the information we're looking for. We need what we want. Like this is only 8 nodes, right? Yeah, it's only 8 nodes. This is only LOD 0, and that's obviously node 0, yeah. So I should probably change these print things for a second. And write the word node. That way, it would just make sense rather than just some numbers. There you go. So node 0 has this many spheres, whatever. Okay, so what we're looking for in the second invocation, and it's being called twice, is it should be going down the tree. It should be going down the tree, but it is not. So something happens here. Stop here. It's probably this guy here, right? Oh, that's a bit of a bugger. Maybe it was fine. I didn't have the right arguments in there. Oh, with what actually can you know when it's shown? I see what you mean. Yeah, I remember you asking this before in the past. Like you want to know basically, you want to be able to get a timestamp of like, hey, this frame was actually presented on the display and the user saw it at this time. So then you can basically do your calculate your delta time better for next frame. Is that right? Right? I don't. I have not looked into that to know. I've not looked into if that's possible. Um, is it possible on Windows to do that, Meatball One? When a frame is being sent to the monitor, it's a sequence of packets. Suppose each packet is not necessarily one frame. Yeah, I guess that information varies between the monitor. Actually, no. It's probably a spec to do with how the HDMI works or whatever, isn't it? Hey, what are you talking about? Fun all the time. Yeah, we're trying to get some complicated shader working, basically. Some LOD clustering system so we can try and render a ton of spheres. Yeah, so I want to see here if we end up stopping here in the second invocation of shader, which builds LOD1. Again, if the stream dies, I'll be right back. But I don't know. All right, we're still running. That's good. So, right, we're not seeing anything here. Interesting. Weird, right? I was expecting to see. So we might be stopping in here. A leaf sphere exists at child. Oh, did we not update the construct LOD? Or did we go out of bounds? Oh, the construct LOD. Oh, no, it got updated. What are we talking about? It's right there. Okay. And this one is going to be like node out of bounds. Okay. All the debugging information. Let's run that. Oh, we found a leaf sphere. So we generated the next. How do we find a leaf sphere? What are you talking about? These are all got no spheres on them. If that's not equal to this guy. This is where I need to debug print this thing. Then we can inspect the bits and bobs, bells and whistles. Oh, come on. I can see. Actually, no, that might be. Yeah, that's the number that you're looking for, right? I can't believe that would have gone and actually indexed into there and not crashed the GPU. Right. Let's try this for a second. Okay, that returns 1. And then it actually goes and indexes into that and it doesn't cry and die. Right, because it probably indexes over 4. I don't know, I don't want to. Ah, I know why. This returns a number that's near the end of the 32-bit integer. This one adds. No. Nah, it doesn't quite. Yeah, I'm still confused. I expect that's crashed GP, but it didn't. Okay, so how do I fix this then? So I think this needs to be 29. Alright, we're in. Okay, so this one reached stop. Okay, so this is fine now. So I have a bit of a... So now we reach this one for some reason sometimes. So stop here when we've constructed a child node. That's been deleted by... So these nodes have... Why isn't that progressing? What is going on? Huh. Stop here when this node was constructed. No, that's not necessarily always true. Stop here as this sort of... Okay, the child node was never made or got deleted by an edit operation. So for some reason the child index is actually the same. So we'll look into that. It's been set to 0 apparently. Hey Clarissa, how you doing? Oh, you found a new job, awesome. Is it in the games industry or that's good to hear. Also, like, what sort of industry is it in, if not? Not bad at all. How are things going? Yeah, things are going good, man. Just been preparing for the holiday, eating tons of food, you know, chilling with the baby. Currently we're trying to get this shader off the ground. Okay, it's off the ground. We're trying to get it to go to the sky right now. We're just trying to get it to work on all the LODs to generate every level of detail from a list of like edit operations on the GPU. And it's going all right. But as soon as we get LOD1 working, then the rest should just work. I just have to test out this code that goes over the edits and does like, you know, you can do multiple of these, add, remove, and all that lot. But we might not need to worry about that to begin with. We kind of just want to focus on getting stuff rendering on the screen probably. So as soon as we get it working, we probably move on to the next shader, basically. Now C# slong, slog. Might do some IBMI. No. Fair play. Yeah, I used to be a C# dev back in the day. Of when I started into programming. I say back in the day like I'm really old, I'm not. Yeah. But at least the job's pleasant, that's awesome. That's what you want, is somewhere nice and you can just enjoy your day, right? That over basically everything. Right. So what we're not going to work. Yeah, so we pointed to the same node, right? Which would have made me. Okay, no. That's good. So why is that happening? So the end of this shader, when it's ran for the first level of detail, right? It's ran twice at the moment, right? LOD 0, LOD 1, yeah. It's already taken this time. Oh no. Yeah, I know it's going to take a long time. I know this shader's not going to be wicked fast. So the end of LOD 1, this thread tried to put down a sphere, but it couldn't. And what I realized is there's a higher LOD sphere that you're painting down, so it needs to place a child down. So you go and place a child down, and we allocate a new node index, right? So I need to do another print. Alloc child node D. So you'll be like, oh, I've got this one here. Wait. Cluster sphere index, that's a child index, right? It's a bit weird, is it? No. And then it's node index. Rightio. Let's give that a go. Let's just double check quick. Is the absolute times by that plus child. I don't see the problemo. So it allocates. We only got one child that got allocated. Alloc 0 node minus 1. Right, so it allocates the leaf node. So yeah, we're only in the lower left side. Are we? No, I put it in the middle. I put the edit thing in the middle of the volume, didn't I? Oh no, I didn't. It's unsigned norm and not signed norm, isn't it? It's unsigned. That's just the lower left. Gotcha. So we're gonna only go down the left hand side on the first LOD, right? Because it's basically just 2562 cubed. So these are each like 60. So they're each like 128, right? And then like we're only doing the lower left or whatever coordinate space it's in, right? So then only this one's going to get made. Yeah, that makes sense. That makes many senses. So we should probably check if the synchronization code actually happened. It got placed. It should have done. Yeah, no, it should have placed sync code. So if the node index, oh damn it, where am I fishing this out? Here, this one. Right. So what I kind of want to do is like say, we'll say dot. And then when you go here, you want to say dot that, and that way we can see the child index is fishing out. When we get down to so many LODs, it's just going this debugging information is going to be too much. But as soon as the first couple of LODs work, it should just be alright. So node 0, child 0 points to node 0 for some reason, which doesn't make too much sense. We should look at this in a bit. I just want to debug this problem. But the first iteration, this is the first iteration print code. So the first dispatch of the shader allocates one child, which is the lower left, right? That makes sense. So that's all good. That's all good. So we stop. So for some reason, these are repeating the same ones. We've got to investigate that. Not yet. We go down. Yeah, actually, that might be fine. But anyway, so we go down to 8 nodes go down to the left, or 8 threads go down to the left. Which makes sense, right? Because on the second time, you have 8 threads going down this tree, and they'll be like, okay, I'm going through this one here, right? And then you've got 8 threads to get one for each sphere. So see if a sphere goes down at that LOD, which it does, right? It goes on all of them. But why is it node 0? This is what's wrong. This should be node -1. So that's not very good. We're not adding. No, that's right. Yeah, we should be fishing out -1. Like, why are we not fishing out -1 from here? Let me just double check that quick. Let's write -1 in there and just check it's not the print code. Yeah, that's what we want to see, right? Because node 0, child 0, right? Put in -1 into that buffer. Apparently. So let's have a gander. Oh, did I come and find the duplicate function signature bug? Yes, I did. So what happens is in the compiler, so that yeah. So basically, we have this sort of like this data type. It lowers down into U32, right? It's just an integer into like a bindless array of buffers or textures or what have you, right? So all of our resources, buffers, and textures do this. But also, this lowers down to this, right? A sort of signed 32-bit integer. So what's happening is in SPIR-V, the signatures need to be deduplicated. But I was when I was deduplicating it, I was doing it in the sort of higher end of the compiler where it was when it was generating the syntax tree, when it was dealing with types in this form before it got lowered. So all I had to do was basically lower them into a sort of what they're going to be in their final form, and then use that in the sort of hash table that deduplicated it, basically. And that was the fix. Yeah. But it is one of those bugs. To me, what a debug, unfortunately, but it's good that it's done now. Yeah. Yeah. Completely blindsided me, that bug. Um, I don't understand how I'm putting stuff into an array and then not go. So I guess we should hard code this, right? So here's what we'll do: is we'll hard code in here. Since we know the number, let's hard code. Let's go. Hey, at 0, we'll put in -1, right? And then up here, we're only going to pull out 0, right? And then it should say -1, right? So let's just see what that's like. Okay, so it's pulling out -1. Yeah. So pulled out -1. And let's double check that, right? Let's maybe not. Yeah, I could. Let's double check that. Put 0 back in there, and then we'll undo it and compile again. Right, there's 0. Good. So undo it. So what we know is we're putting in. Okay. The values, and they do get read out. So there's nothing to do with the synchronization code. Oh, excuse me. So it's probably something to do with the index. Confusing enough. So we're going to add another integer at the end. And it's just going to be that. And then when we do that again here, and just see what that integer is that we're indexing at. Man, printfs and shaders, we need them. Damn it, they're the same bloody integer. So have I just indexed that out of bounds, basically, at this point? And if so, that should have surely crashed the GPU. And if so, have the drivers been updated and got fixed where it doesn't crash anymore? I don't know. I'm confused, but let me just double check the buffer rate. So it's like children nodes buffer. So it's max. Yes, we haven't allocated enough. Yes. Sorry, we've allocated enough, but I'm using the wrong way of indexing into it. So what I've done is I've allocated max non-leaf nodes children counts, because surely leaf nodes by definition don't have any children. So the way I'm indexing into the buffer at the moment is as if leaf nodes are part of the equation, right? But instead it should actually be without, I should index without the leaf nodes. So the leaf nodes, for those who don't know, we basically have a little, here it is. We have a buffer, right? We have this sort of midpoint cursor, and this is where the array technically starts. Before the array, this is where the leaf nodes go, and after the array, this is where the non-leaf nodes go. So basically, I'm adding this midpoint cursor, right, to the signed index to make these negative numbers positive again, right? And then these will shuffle along in terms of the index. So what we need to actually do instead is use the signed integer. But we should know the safety check. We should also have another safety check to say, hey, if this is less than 0, then it's a leaf node, right? We shouldn't have found a leaf node while descending down the tree. Right, we should only end up at a leaf node. So this way we can assume that this number is obviously 0 or more. Hopefully that all just combines together and jobs are good. So I can print here and just say node is a leaf. So I found a leaf node too early, basically. So we're looking at and we'll delete all that. So this index into here just needs to, it doesn't need to be this absolute cluster where we add that midpoint cursor. It's just the standard. And this one here is the same deal. Now, where we allocate the allocate child node. Yeah, this shouldn't be a leaf. Yeah, you kind of want to know if this thing is a leaf or not. Yeah, I want to put some safety in here maybe. Well, yeah, I was thinking maybe we should put some safety on these target LODs and cluster LODs to make sure they don't go out of bounds. And should be alright. Let's just YOLO it. Right, so give this a run now. Okay, we're getting what we want. Good. So the first dispatch does LOD 0. It has one thread for each sphere in the cluster. And it will, we've only got an ellipse that's covering the lower left-hand side. So only one of these guys puts down a child. And it allocates node -1. And it knows it's a leaf node because so it's -1, it's negative, so it's a leaf node, and we know to place down a leaf node because the thing that was drawn down is on the next LOD. We see that in the code somewhere here where we say, hey, if the target LOD here, if the target LOD is greater than the one that we're constructing, make sure we have a allocate child node at the end of this shader, and then it says here, it is a leaf node so long as all the previous ones that went here, and this one is the target LOD is 1 plus the construct LOD, right? Okay. So this is looking good. Each one of those child nodes is getting a sphere. So that's getting a full cluster. So LOD 1 here. This is getting filled with spheres. That's good. So now, really the rest of it should work. The bits that we should have to be testing after this is mainly like, what's the word? What's the way of saying it? Yeah, it's mainly like this code here where we're sort of adding and removing stuff. But I'm inclined to skip some of that because I know we've got something working, and this should just scale all the way up. Wait, maybe there's something here. Yeah, okay. Let's do one more level and just look at it, and then if that's fine, we should just be able to do the rest. And I'll take off all the print code. And we'll move on to the next shader. It'd be good to get something visual up and running at ASAP, basically. So we're going to have this edit that we're painting down, brush over the LOD2, and we'll up this to say we're launching another shader. And so we sync there and give it a run. So we should probably have some print code. Actually, no, that's fine. What have got separators? All right, the stream is still running. This is good. Tons of printing. This is great. So this is the first launch, LOD0. Then this is the second launch from here onwards until I figure out where the end is. Well, the end should end in these, basically, these allocs. Or this sort of stuff. Stop, not child. So this is where we've tried to go down. We're generating LOD1. And we've tried to go down these guys, but there's no child node for us to traverse down, so we just stopped there, right? That's because the edit that we painted sort of just drew over this space, so it didn't really touch these guys. So that's cool. So that's saying, yeah, so that should be eight times. Wait a minute. Should be. Oh, yeah, okay. Yeah, it should be the rest of the 32 threads, basically. Oh, threads. So these are the threads that got through. And they were like, oh, come on. The integer's not right again. That's not good. They should have traversed to... Yes, so what it's done is it's allocated itself. Right, so that's the thing we needed to test. So it's gone and allocated itself. So this, surely I set this as something sensible. But this is set to 1, because this is the root node. Right. So 1. So set to 1 because we're allocating the root node, and this is it. Okay, so that was a problem. So I guess let's just restart that. And all right, now we're seeing something interesting here. Excellent. So now we traverse down. So this is all fine, right? This hasn't changed. Now we traverse down on LOD1. On the construction for LOD1. We traverse down from LOD0 to LOD1, and we go to node 1, right, from node 0. Node 0, child 0. And then when we're trying to let me use it back. When we allocate the child, sorry. Now we're trying to construct LOD 1 for this cluster, which has got 8 spheres in it. Then we realize, you know, we've not got any edits which are painted down specifically for this LOD, so we'll allocate the children that we need. Apparently there's only one that's got made. That probably makes sense. It might not be big enough yet. So then this is LOD2 being generated, where they're the size of 64. Yeah, that does make sense. Yeah, it does make sense. Okay, so then all of these guys get transitioned down from LOD0 to LOD1 as they're traversing down. Then they've do the next iteration and realize, oh yeah, we're going to stop here because there's no children. And then these guys, which only, so there's only one cluster on the lower left again, right? So we're on the lower left one traversing down into the next LOD2. And then we're at node -1, which is the first leaf sphere, or leaf node. And we generate some spheres. And apparently there's 4, right? 4 spheres. Because we've got this ellipse which is being painted down. Well, technically it's a sphere. Because we haven't, yeah, anyway. So it's like that. So so this lands in the canvas down at LOD2, and it's like, well, there's only 4 that go in here. So it could be like that, and then one near and far one, or one near or far one, something like that. I don't quite know. Whatever it is, right? Well, no, it'd be 3 across this axis, and it might be 1 like that. I don't know. But it's something. But as we increase the LOD, that's going to become more, and there'll be more clusters that show up, basically. So I feel like this is actually working. So we're going to add this, we're going to increase it by 1 until we reach the top LOD. And then we'll, see, part of me is thinking like a safety thing, like, if we go above, like if this, like this is pretty like these two I guess could be dangerous if they go out of bounds. So we should probably safeguard those in the shader. So we should probably say, we should probably do something like this. Or we say E32 target LOD equals min E32. What is it? Data LOD count -1. So I think there's 8 LODs. And then we kind of want to have something like that for the construct LOD. We want to do it, we want to stop this thing even running. If the construct LOD is greater than or equal to 8, then we want to kind of just, you know, return there and not let it go on, because that's just going to create some problems if I ever accidentally do that right with invalid data. So we should just quickly adjust some of this code here. Use the new local variable instead. And was this the old code? No, it's gone all the way around. Okay. Right. So that's cool, but there's one more thing. There's that palette material index. So this guy technically should just be minned with like how big the material palette is. And then as soon as we've done that, that ought to be good enough. I just gotta find Right, it's got 4 on it anyway. Oh no, but we've changed it, isn't it? Oh no, we didn't manually pack it. No. What did we manually pack? Did we manually pack something last stream? Oh no, maybe we saving the packing for later manually. For reasons. Because we might change it. And it's just easier to work with that for now. Okay, so let's slowly increase what we're launching. So we're going to go to, that's right here. So increase to 3, increase to 3. Oh yeah, we want to delete the printing code, right? Want to delete, just comment it out, because 1, it's going to fill up the print buffer, and 2, yeah, it's going to fill up the print buffer basically. We might keep 1 on just to see the results. Let's just say which, like, the number of spheres for a certain node, yeah. That'd be a good one to see. Right, so we've gone up by 1. We're on LOD up to LOD 3 now, so it's 4 LODs. We only saw 1 node get 4. I don't know if that makes sense. Let's go up 1 more and see if there's any 1 node. Okay, I think we're gonna have to investigate this because that's not working. Alright, let's bring these back then. So when you traverse down, right? See, we're not really seeing like locations of where these things are, so it's a little bit difficult to see. And we're not necessarily seeing LODs, we're seeing node traversing things, right? But that landed on a leaf -4, right? Where's the other negatives? Because if you got to -4, like, where's the other guys? But that's a bit, it's a bit skeptical to me, you know. Right, these stop not childs need to sort of just get out of my face. There's too many. Alright. I've not seen the alloc ones anymore. I think I didn't remove that comment, to be honest. Sounds like it makes sense. It's right here. Uh-huh. Okay, so we're allocating some negatives here. Um, so why aren't they traversing? So from here, damn it. Okay, so quite a lot of threads went down. From there to there. Child index 4. But if these ones made a leaf, they should have all traversed down. So it could be to do with the dispatch. We've not launched enough threads on the dispatch or something like this. Um, yeah, it could be the dispatch arguments. Hmm. No, I think it's okay. I think we need to sort of say um, where the nodes actually are. There's a lot of stuff that's being printed out. Um, but also the way you should probably print these is do one thread. We'll do something like this, right? Let's move this stuff around. We need something like this where we if guard it, where we say the first thread uh, of the 8 threads that are together, print out the code basically. And that way there'll be less noise and it's easier to sort of read what's going on. Hey there, Buffer Overflow, how's it going? Welcome, welcome. How are we doing? So this will stop printing out tons and tons of crap and help us hopefully focus on what's going on. But we kind of need to print out like, this one is at this location. Or maybe we print that information right out here, just the once, so we can see it. Right. Generating or gen node. So gen node this, and then we'll print out like it's the details, right? Where it is in the. So we'll do like indexing things, right? So I think we'll do node. Is that what it is? Cluster, yeah, location left. Excellent. Left near. Rightio, so we sync back, give it a run. Right. I was supposed to see stuff pretty consistent. Okay, so the location isn't actually being set properly. It's only doing the actual lower left node. It's not. Yeah, I don't know what that is. It's not able to do any more than the lower left node of every cluster. Aha. There's an idea of what's going on. So why? But is it able to do it? Because it kind of like flip flops. Let's have a think about that. So why would it only go down to the left? What is going on? It must be. It must be to do with the way we're the way we're making these the index and seeing whether or not it overlaps with the sphere. You see, when we if it overlaps with the edit thing. Oh my days. Must be. So coordinate highest LOD, right? And I doubt these things are actually hitting. Um. So how do I? We kind of want to. We want to test. Okay, so we move this to the mid. Oh no, it's not a good one. Yeah, let's bring it back down to LOD 1 that we're generating. That might be a good enough one. And then we'll see if it generates. So bring it back to generate LOD 1. Then if we say, so let it do that. And we'll move the edit thing to be in the middle of, so I think it's 64, right? Because 128 is in the middle there, right? 64 is there. And then we want to put something that's 40 big. And so this should generate all of these guys in LOD1, right? And that's what we're trying to see. If it does that. And if it doesn't, then there's a problem there. But I could have we saw it do that anyway. I don't know, it's just C, right? Okay, so according to the... So on the first iteration, it generates node 0. It goes over all these guys. And then allocates some leaf nodes. No, what is going on? This ain't right. I would expect more to happen. That should say no child in that error message. It should say, sorry, not child, it should say no child. Okay, so something's fishy here. This is not even, it's only doing one iteration. And it's not doing a second one, but it's generating 4 children. And make it a bit smaller. Hmm. This is the end of the first shader. LOD shader. It shouldn't be generating 4. Like, I guess the problem is like some of the code where we're doing the like if your position we should print out the other code here to see if it actually hits anything. Yes, it's hitting 4 nodes. Yeah, I'm not sure which ones it is. But I could have swore. Right, saying the half dims are 142 when it's extended it. Because we've got 32, isn't it, on the thing? Wait, so what's the half dims of the... Because it's an ellipse. Hmm. Yeah, it's because it's an ellipse and I've expanded it. So there's this bit of code where we're trying to basically cheat. I have a nice simple way to test. So you've got this like edit shape. Here's the diagram. So basically you've got this like so you've got this ellipse that we're drawing down, and effectively you got this point here in the middle. Okay, so maybe we're drawing it down here or whatever, and it just about overlaps this uh, what this cell inside the this sort of 2 by 2 by 2 area, and we want to make sure that we place down a sphere in this cell because this thing has just about touched this cell. So rather than doing like a ellipse verse box, I was trying to simplify it and do a point verse ellipse by extending the size of the ellipse. But the way I'm expanding the size of the ellipse to the bigger one, I'm expanding it based on like the half of this. The way I tried to expand it by the half, but the problem is it doesn't do the corners. Wait, what was it? If you take a sphere, if you extend the radius of a sphere by that, you know, it's just doing it. It's not doing it enough. So I thought I'd do the length, you know, do it. Yeah, I'm doing something a little bit wrong. I want to get probably this one, this line here. So I've got these 2 lines basically. It's just distance of those 2 lines, or 3 lines really, because it's in 3D. But yeah. Probably the issue. So you've got these 2. Like that is just basically these 2 squared, or these 2 squared, then added together square root or something like that, isn't it? I forgot. But even, is it the right thing to do? That's the question. Yes, square the two components, or three in this case, and square root it. But is that the right thing to do? Because that's going to increase it by a bit too much for this, and it will make it even bigger, which means these things get messed up also. Yeah, which means it could go a bit too far. Yeah, maybe that was the wrong idea. I think that was the wrong idea. But anyway, that's not the problem per se, but it is an issue. So if we run this again, right, it's doing more now, I think. Okay, so this is the first, this is LOD 0. And it says we're colliding, oh damn it. Why are we colliding with so many things? So we've got this position at 64, right? Ah, no, we're not colliding. Damn it, I hate this thing. I hate this thing. It's inverted to how I think. Let's change it. We want to say this is like a yeah, this is just the wrong way of thinking about it. You want to say this this sort of intersects or has intersected. That's probably the better way of saying it. So this needs to be reversed. Okay, so the data's reading fine. Right, so only one of them intersects on the first, on LOD 0, right? Then we allocate one node, excellent. Now we're generating for LOD 1. These are all the spheres which are being generated. These are all the positions. And we do all of them apparently. Okay, interesting. So that's okay. Let's up it by one more. Because I could have swore there was an issue when we start going past here. Well, it was a bit higher when we already noticed it, but... Right, so here's LOD. LOD 1. And then it intersects them all, allocates a child for each of those. This is fine. Now, on the next time when we iterate down for LOD 2, we go down from LOD 0 to 1. And then we stop because there's no child. Now, this is weird because... So apparently, -1 to 7, right? Don't have their children, but there is one for 8. So then A gets generated. So this is where the problem is, right? So apparently we do allocate them, but they don't for some reason get set. Which is weird. So I think we're gonna have to do that debug thing that we did before, where we just put in the whole index and just be like, what's going on here? So there's a bit set. There should be a big old barrier between them. So that should be alright, that should be written. Because we're checking this bit set to see if we actually if there is a child and if we can continue on. And then we write that in there. Right, let's put the number in again. I want to do like just do that at the end. And this is where we read it out. And we'll do the same thing again, right? So let's just read what sort of indexes it's reading and writing to. Sorry, I put it in the wrong place. I need to put it here where it fails. Whoopsie. What's going on here? Child index. Whoops. Let's type that. Okay, so we tried to, so when we allocate it, we put it in 8, 9, 10, 11, 12, right? And then we're trying to read it out in the same place. Okay. Oh, it's nothing to do with the reading. It's purely to do with the bit field, isn't it? Obviously, because that's how we land in here. Okay, so it's nothing to do with that. So it's purely to do with the bit field. Here's the bit field. Child index. So we know they're the right numbers, right? So why then? So the bit I'm confused about. So this thing is being written, or it's okay. Like we're printing out here alloc child with this guy, yeah. And we're using that same thing here. So surely, and this node index is going in here. So it's working fine for a non-zero value, right? For child 7. I need to look at the bits. So do I get an integer back? Like some old bits? Well, I get some old bits back. But they'll probably all be writing at the same time, to be honest. Isn't that right? Yeah, they'll be writing in lockstep, you see. 8 threads will be running lockstep this. So what we could do is do a... I wonder if we should use wave intrinsics. it's quite difficult because we've got 8 threads that are on the same node, but then there's like 4 nodes per wave. So the problem, like, uh, you wanna, you kind of want to like join them all together. So I could put them. I can use wave intrinsics to do it. I can put them in the 32-bit instance, shift it about, and get the bits I want specifically for this. For this, and then do a single write. Yeah, they're all kind of writing to the same place. I don't see the problem with the code other than the fact that it's probably not as performant as doing something locally first and then doing it in one go, right? I don't see a problem with that piece of code, but it seems to be the case that's causing the issue. So this one, so we know it's something to do with the indices because we alloc 0 here and then we go and use it. So it would just be nice to probably see the bits. Like, it might be good to see the bits, the child bits. But I don't know where is best. So here we're clearing out the new node which we're making, right? Which is different from the node that we've been generating on. Because that's his parent node, right? Which is this guy here, the parent node. So using the absolute one of these guys is correct. Store out the yeah. Let's print out these flags at the end. I'm just going to print it out as a number. Because I don't think we have hex form. Oh no, do I have hex form? I think I do. I think I did that. Yeah, here we go. So it's in hex notation. Okay, so we allocate the... Right. That's very, very weird. So apparently... Oh. Crap is going on there. So we get a 1, which is... Well, you specify 1 shift left 1, 1 shift left 2, and so on. But then they get cleared. Like, they're sort of getting cleared at the same time. So I wonder why... So 3 is the 2 low bits. 6 is the... I forget what 6 is. Yeah, I have to calculate back out. Alright, 6 is the... Yeah, it's just like it's cleared the lower bit somehow. So something's fishy. It could be with my compiler. It'd be interesting to like, let's remove this part. This will tell us what it was before it wrote it. Right. One, 2, 4, 8. So when it wrote these guys, that seemed pretty fine. I don't feel like this is ORing at all. This is just doing a store. It's just doing a store, damn it. Right, so I guess we can see it's right at the end of the shader. Right, so we can just do, we can basically do something like this. I was hoping to be able to run the shader code. Right, I have trouble yanking out of this thing. Yeah, let me cat it. Right. Right, so if we, yeah, so I want to put on the end, I want to see, no, I could probably just do with disassembling the binary. It's got to know the exact shader. Well, we can kind of just look for an instruction, right? So basically we're doing like a bitwise OR. Atomic OR. So we don't see an atomic OR. Wait. Big pipe. Oh, I did the dash R. Whoopsie. So there's just a bunch of atomic stores and stuff. So I could have swore we've done exchanges, but maybe we've not tested the atomic bit ors then. That's probably it. Alright, let's get into that compiler code and have a bit of a jam. So basically in the SPIR-V, what'll be in? With the SPIR-V gen, let's look for atomic. Yeah, right, so we should check our abstract machine language and see what atomic instruction we have. Oh, the number is wrong. Oh, it is, the number is wrong. Right, so that's probably the issue, right? That was set to probably what store was. Oh, no, it's not. Oh. What was that set to? 39. It was set to Umax. Whoopsie. Oh, yeah, it's right there in front of my face. Copy paste. A wonderful tool. Alright. Luckily it wasn't too hard to find. So let's build a new version of that. Ready spill, please. So we get the super juicy compile times. Sorry. Get the latest compiler build. Okay, so I think we found our bug now, so this LOD thing should just work. TM. Well, hey, there you go. So there's a bunch of spheres, all on those leaf nodes. Cool. So let's keep going up the chain now. So what I want to do is delete the. I want to remove all the printing, well, most of the printing. I want to keep that one here to see how many spheres are down, so we can just see if it just makes sense, and then we can just go on to another shader today, which would be super sweet. Super duper sweet. So we go to, yeah, so we just run it now, where you'll see, oh, was that jumping? That seemed skeptical to me. Maybe it's just the thing jumping around because the different of the printing code. Ah. Okay, that's probably okay. That's just basically the atomic number returning a bit. Each wave was getting a different, like they're getting the same number. So each thread in the wave was getting it from low to high, but then it sort of messed up on this iteration a bit. But that doesn't matter. That's just still linear, right? That's cool. So let's increase the amount of generation. Let's go down to LOD 3 now. So we should maybe be seeing more nodes show up. Yeah, it's probably split across 2 different work groups or something. Oh no, it won't be. No, that's wrong. Anyway, what? Ah, yes, okay. So we've got each node is a cluster. So we've got these clusters. So the time before there was 4 in each cluster. Okay, 1 in each cluster. Now we've split them down to the next level of detail with 7, which means in the next one there's going to be more clusters with maybe less spheres. So we'll go up to LOD 4. So we should be able to go up to LOD 8, I think. No, LOD 7, that's the biggest. Here we go. Right, so now we've got more clusters. Some with 8, some with 4. Okay, yeah, obviously some of them are going to be 4, that makes sense. Okay, fill with spheres. Alright, things are happening. So we got up to 5. Let's run that. So even when we're printing, it's still not taking too long. I think the thing that's going to take the longest is when you have like thousands of edit operations when you make your models, right? Okay, so now we've got even more of these guys, right? It makes sense. Okay, I'm just starting to think this is just okay. So let's just put it up to 7 because I'm feeling good about that. And let's comment out the all right, let's leave the print code in, but yeah, we'll just see it. There you go. It looks like a really big number, right? And that's because it probably is going to be a massive number. We've only gone down like the lower left side, lower left near side of the first LOD in a sense, right? We've put our, so in this LOD in a sense, right? Not specifically, but in this specific point in the whole volume as a whole, we've got a sphere which is about 32 in size. So it's going to go down and it'll be in the middle here, right? Because this one points to here, it'll be in the middle there, like that. And then it will, anyway, as you go on. So we're progressively given that detail. So, 256 cubed is this number here, but obviously that's not how many nodes we'll have. What we'll have is 128 cubed. So that's the most number of nodes we'll have. So this seems like it kind of makes sense, that number, LOD7. So we can't go any higher. So we're going to comment out the this one, and we'll just assume it's all fine. So here's the 7. It should be 8, right? 4, 8. Pretty good. So you see that last one? It takes the most time, and we don't necessarily do much, right? We're not processing. We're not processing. We're not processing lots of not processing lots of edits, basically, with people editing and stuff like that. So we've got to really be careful about this shader, how it runs. Though we've probably got to optimize whatever the slow part is of this. We've got to find it. Maybe simply changing this one line and expanding it to like a few lines and doing some wave intrinsics helps out. Maybe, we've got to just see which where the hotspots are in the code. But for now, that's not really a problem, but it's just a case. Because I did want to have some time in the budget, in the frame budget, to sort of run this shader, right? Or maybe we partially run it. That's probably the other way. Maybe it takes a few frames to do I don't know. That's another way of doing it. You can run this over 2 frames, like do half it in one, half it in another. If it really takes into the budget that much. Okay. So I think the next shader we want to work on is this one here, generate an occupation map. So an occupation map is we need a way to quickly, okay, let's describe what we've done here. We've constructed a cluster tree of spheres, basically. And we've found where all the leaf spheres go, and we've put them down. So we've not done any lower LOD spheres. So imagine you've filled like a 256 cubed volume, right? You're not going to want, you basically only want the detail around the edge. You might have like filled all of this space here, but really you only need the detail around the edge, right? So what we have done is, what we need to do now is we need to build so we've got it in a tree. A tree is terrible to sort of to look up your neighbors. A tree is terrible because the problem is you've got these 2x2x2 clusters. So if you've got this sphere here, or okay, what's the way of saying it? You got this cluster here which is filled with spheres, right? And you're trying to say, hey, my neighboring clusters, right, which would come from this one here, right, And this one will come from, wait a minute, we go up. This one all the way down to here, this guy. So you see that took me a bit to go and do that. Now imagine a computer doing that like hundreds of thousands of times. It's going to be pretty slow, right? And it's got to find out whether its neighbor is here and filled with spheres. So why do we want to find out the neighbors so bad? So specifically the task is, right, this is the task. If a cluster is surrounded by other clusters, there needs to be no information, like you can get rid of all this level of detail information. You can all this higher level of detail, you can basically simplify it to this lower level of detail, and then you repeat that and go until you have no neighboring, until you're not surrounded, right? So this occupation map is that surrounding information. So we're using a bit set to where each bit is a cluster, and we're kind of doing this like neat little trick, which kind of makes it a little bit more confusing, but it should be able to go over, and it should make sense. So effectively, you can imagine each bit in a bit set, right, gets it is a cluster. So, but then you've got another problem, right? So imagine you've got a 32-bit integer which does a 4x4x2. So you'll get here it is. Here's one I made earlier. So you got a 4x4x2 bit set. So there's another slice of this behind. So the problem with this is, say if you look here, say if you got this cluster here, and you're trying to check if I'm surrounded. Well, you need to check all these bits and the bits that are on the next slice, or the next bit set to the right, and you've got to check, like, you know, these bits here, for instance, and also because it's 3D, you've got kind of like the ones behind and in front, right? So technically you could be sampling 4 or more bit sets, and you kind of got to do some complicated code to see which bits you want out of those bit sets and bring those all together. So it gets quite complicated and confusing. So the way we solve this problem is we basically just duplicate the data in the bit sets, and you only sample from within this area. Sorry, your cluster that you're sampling from is only within this. Sorry, the cluster you're trying to see, which is surrounded, is only in these spaces, and then you've just basically got it. So say if you want to see this cluster, this would be the first cluster. You can just check all those bits around here, and obviously the ones in the other slice behind it, or whatever. Yeah. So at most you have to bring up two. You have to sample 2 bit sets. Is that right? Yeah. You have to sample 2 bit sets because it's a 4x4x2, and obviously you've got because it's 4x4x2, you've got another slice behind here in the bit set, right? But then you've still kind of, because it's 3D, you need one in front and behind. Right, so you need to go and grab the bit set before or after, that sort of thing. So this means that within 2 samples, and with a constant number of samples as well, we can basically heavily simplify the code on how we sample this thing. And it's pretty neat, actually. So we just basically repeat the data. So this is how we build it in here. The sample code is here. It looks a little bit like it looks a little bit crazy, but in terms of like how much we're able to check in such little code is quite impressive, basically. So you've got this sort of, there's one row, the next row, and the next row of bits. So these are clusters, right? And there's your sample position. So that's what E0 means, right? So we effectively get this in the sort of top left-hand side, and we just like shuffle it into the right place with these sort of shifts. So the most it would be is either here or to the right by one, or here or down by one, or these two bit sets. Depending on the Z component as well, you might have to just shift it like that, basically. So that's pretty neat. So there's only two samples that we can check like all the clusters around us. So yeah. Yeah. So in this bit set, there's another thing to take note. On the furthest top left, not even the furthest top left, around the edges of the whole bit set, they're all empty. And they don't contribute to, like, these are, you can't, none of these, like, we always offset by one basically to sort of nudge past the empty border. So the first cluster goes here, right? The first cluster bit is here on the first top left or whatever, right? And the next one goes there and there and there in a sense. And then if you want to try and put one here, you don't put it there. You put it in the next. You put it in the next one to the right, and you'll put it here. So you put it in this one over to the. No, sorry. Actually, I did that completely wrong. Let's undo that. So the only places you fill in this generate occupation map, this is it. You only fill in these ones here. Now, because there's that border on the first one, you basically only... So the first guy goes there and the other one goes... Wait, and that's it. So we're only really allowed to write to this position on the first one. But then when you write to the... You want to write to your cluster one to the right, you write it here. You write it there. And that's going to put it here. Yeah, and then we reach back and put it in the one before us. And then if say we want to put one here, we reach back and put it into the one before us. And that's basically how the system works. So we have some wastage on the final ones to the right-hand side and the bottom or something like that, or whatever the coordinate system is. So we have some wastage there. So here's the reach back code. And there's some extra sort of writes. But when it comes to reading, it's like heavily simplified, right? So yeah, that's the basic idea. That's all we're doing. So we should be able to visualize this in RenderDoc and just see slices of the model show up. So we should be able to see something today at least. Which should be pretty sweet. I'm gonna play the same one. So the really great thing about this shader as well is we're launching over all the leaf nodes and then we're going up the tree. No, wait. Sorry, we're not going up the tree. We're just launching over all the leaf nodes where all the spheres sit, right? And if you remember from earlier, we've got this lovely thing where we've got this midpoint cursor and everything that's in the negative numbers is a leaf node, so it's contiguous in memory. Excellent. So we just need to know the number of leaf nodes that we're launching over, and bam. We can just get the node information. So that's how we've got to set this thing up. So let's go ahead and get this launch code together. Let's just figure out how we're going to do this. Be careful how I type, it's shaking. It's heavy water. Oh well. go. So what I'm going to do is do some bundle constants. So basically push constants, right? That's all they are. Nothing special. Just a little bit of information you pass to every shader, and it's amazing. Okay, is that... Did I not budge anything? Good. Alright, so this is just these. This one. So this shader again needs to run like as many times... Wait, no. It needs to run once, and then we run our special downsampler. That's the shader afterwards. Oh, this is going to be great. This is going to be so good. So this one needs to be the occupation map. Have I ever made this thing? I haven't made this thing yet. So... What is it called again? Occupation map. But I need 9 of them. We need 1 for every LOD. Oh, it is, isn't it? Yeah, gotcha. No, this is gonna be so good. So what was that again? Oh yeah. Wait, did I call it the volume? Cluster occupation, exactly, that's what it's called. So cluster, I should really call it constructor, because then this is like the volume constructor work, right? Cluster occupation map. Isn't she lovely? Look at that. Buff ready. Maybe I should put this in a structure, but anyway. One day we'll get there. So this will just go here, and it's not a buffer, it is a texture 3D. Now we're going to have different MIPs, but for now this ought to be good enough. This is the cluster occupation map. Now, how might one make such thing? So this needs to be the full dimensions of the... Right, that's not the number I'm looking... Okay, it's the number I'm looking for, that's not the constant I'm looking for. Cluster dim. Did that get deleted? That got scrubbed off the edge. What? That's meant to be 256. Okay. Right, we use this in future shaders. Okay, I was wondering. That's why. Right, so cluster dim. This is the boy we want. So cluster dim, cluster dim, cluster dim. Now I think there's like a number of MIPS or whatever. I just gotta. That's why I hate the number of parameters being more than a few. Ah, right. Completely scruffed it. Texture 3D. Right. GPU resource type texture 3D. GPU format none. Is that the sample? Like we're saying we're not sampling it, right? Or is that storage? Storage format and then sample format, right? So we're not sampling it, but we are storing into it. So the storage format, it's a U32. Excellent. And then we want to do one of those cluster dim. So on 3 dimensions of that, please. Then I want 1 MIP and 1 array slice thing, whatever. Obviously we'll change that MIP one in a bit. But for now that ought to be good enough. So, now we've got this lovely thing. Now what we need to do is throw that in the right place. There it goes. So there's the occupation map sorted out. Now we're going to get the synchronization code in. So it should be, I think we're reading over the clusters. And I think we're writing to read write to the occupation map, right? So let's just quickly double check that. Read only, read write, bam. Excellent. So down in here we've got to do a lovely dispatch. So we dispatch, and what we're going to dispatch over is volume cluster, whatever. Just find that. How many of these boys we're launching? So I think we do one per node. So we just need the number of leaf nodes. Now I think this might be an indirect call, where we basically we have to have this populated by a shader where yeah, so we're probably going to do indirect. Hey, what are you doing actually? I see in the description an engine. So we're writing a game without an engine. That's the long-term goal. But right now, we're making a sort of let's see if I get this thing up and running. So we're trying to build like a world out of spheres. Here's like an instance model that we've got working. It's like an old renderer. It's like ray trace spheres. But we're trying to build like a more scalable solution. So we're building a set of we're building like an LOD system basically, and clusters of spheres that we're storing into GP memory. So we're trying to generate that in GP memory right now. We're able to generate the initial tree, but we're gonna have to simplify it and generate the lower levels of detail. That's what we're kind of working on right now. But yeah. So we're working on the rendering technology first, try and find like what sort of interesting stuff can we do, and then after that we're going to design a game and work towards that basically and write the technology that we need to achieve that. But yeah, that's what we're working on. Hey, Steve Mushroom, good to see you. How you doing? Thank you. Yeah, so we're kind of writing. We're trying not to write like a general purpose engine. We're trying to write a very specialized engine for the game. But we'll see how that goes because you know how sort of you know, it's very easy to get sort of interested in developing something too much. You know what I mean? Over engineer. So yeah, we're not really yeah, we've not really got like a general engine at all, basically. And random question: how would you like, or how would you render a circle? The best way to render a circle, or the simplest way, is just render a quad, and then just check if you're within the radius, whether the pixel that you're rendering is within the radius. Right. So you render a quad which is big enough to fit the circle in, and then you check the pixels in the radius. And that's probably the best way, the easiest way. Or you can try and put vertices all the way around a sphere, around a circle if you want. That's another way to do it. But yeah. So No, no shader messing with the verts. Let me show you a shader toy. So here you go. So this one is, so this is a 2D sign distance field. So sign distance just means a distance to the edge, right, of said shape. That's all it is. It's a distance. And a distance means from a point, right, from a point that you're sampling, get the distance. You don't know, with that information, you don't know where the edge is. You just know it's that distance away, say 5. So it could be 5 to the right, 5 up, 5 down, 5 left, or in between any of those. So it intrinsically builds a circle, and this is why you're seeing this circle here that I'm moving. But the circle you're interested in is this guy, right? So you can basically you can use a sign distance from edge, where this point is a relative point from the middle of the circle that you're trying to draw, and you're just saying like you get the length of that, right? The length of there to the sample. So this is like this is the pixel you're trying to draw, and that p is a vector. Oh, that p is a vector from here to that sample point, from the pixel you're trying to draw. It's just a relative vector from there to there. You do the length of that, and then you're checking if it, then you're taking radius from it or whatever, and that will give you the distance from the edge. And this will give you a -2, which means you're on the inside, right? As an example. And then you can basically use that information to tell if you're on the inside or outside of sphere and color it in a circle. And all you need to do is render 2 triangles, right? That basically just go exactly around the edge of this guy, right? A quad exactly around there, and jobs are good. Does that all make sense? Hey, Sofam, how you doing? You already have a quad, excellent. Yeah, exactly, yeah, struggling to do it, it's your quad, mate. You think you understand, but you're lost. Perfect. It means it's time to learn. You got this. So in the pixel shader, it's dead simple. Just like, well, it's not dead simple, but it's dead, like, I'm sure you can work it out. You got this. Like, you just need to generate. So I think you get frag coord. This is a bit confusing because it's how the way render doc works, I think. Yeah, no, it turns it into a normalized space. You might not care about that. So say if you change this, you just put in frag coord, right? And then say if you say 30 pixels radius, yeah. Now try that. Huh? Maybe not. Or you might need to offset that, it's a little bit off. Offset that by, I don't know, 250 pixels. Yeah, so here it is over here in pixel space. So the thing's been a bit buggered. But yeah, you just need to use that frag coord intrinsic in GLSL. I forgot what it's called. And you just need to like, this will give you your pixel. Sorry, yeah, this will give you a pixel. So you'll be like, hey, so you'll say like, hey, the center of the center position is the width and height of my Ooh. So that gives me the width and height of the quad that's being drawn, technically. It's the resolution. So whatever that is, divided by 2. And probably you want to offset. Actually, no, is it even right? Ah, I'm a little bit confused now. Because that's a vector, isn't it? Lower left. Mm-hmm. So you want to go from here. It's that, isn't it? Something like that then. Yeah, there you go, that centers it. Yeah, so just monkey around and I'm sure you'll work it out. You get the pie part, but all I got is this simple texture shader. Not sure what you mean. But yeah, I think you anyway, and then you get this distance back, and if this distance is less than 0, you can then texture it however you want. You can just be like, so that this person makes a color here, but you can just say, hey, if it's less than 0, make it red, or make it white. If not, make it black, right? Something like that. GLSL, you're killing me. Constructed too many arguments? Well. That kind of failed. What is going on? Oh, because there's another one. Is there? There you go. So you just basically color it based on the distance. Yeah, you can do it with textures. Easy. Like, this is just a way to discard. You can think of this as a mask, right? If d less than 0, return. Don't draw the pixel, right? Or discard, whatever it is, right? Discard. Discard the pixel. And then if not, you just sample with the UV coordinate, right? You use your standard UV and just sample from the texture at some UV, right? And get your color. That's basically what you need to do. Yeah, so where to go? Yeah, you can use the uniform sample texture the same old way. So you basically texture that quad. So if you can texture that quad, fine. Right, however you want to texture it. And then you can use that sign distance field to sort of discard the pixels that you don't want. But another way of doing it is just using a texture which has the alpha pixels. That's the other way of doing it. Draw a quad. Draw a quad which has the alpha pixels and they're transparent and then it won't render it. That's another way of doing it. Huh? You just sample the same way. Yeah. Just draw a quad with alpha, with a texture with invisible pixels, and then that'll work. That's probably the easier way if you don't want to learn that sign distance field thing. Hey, did that lowercase everything? Drop one on there. Oh, no, I didn't. Yeah, that's probably the easiest method, actually. I just like Sanderson's fields, you know. Right, so going back to this occupation map. This amazing occupation map. We just need to launch based on the number of nodes. Oh, yeah, it was an indirect. Indirect. So where's the indirect args going to go? I've got this global buffer. So I could just chuck it in there. So we just need to poke. Right? We need to poke in there. GPU. GPU. See, I don't really have this thing as like a... yeah, I don't really have like a structure for it. It doesn't really matter. It's just one of these boys, right? It's just 3 of them. So this is the volume. So useful in constructing the volume. Volume occupation map indirect args. So when we initialize that constructor reset, so the volume constructor, we're going to go and initialize all these boys to 0. Wait a minute, it's .x, isn't it? .x, wait, even better. 0, 1, 1. So 0 on the x, because x is the number of that's groups, isn't it? You know, I might have to launch another shader just to do this, because it's the number of groups we're launching. Yeah. Okay. Right, new shader. One, one, one. Indirect args. So it just populates the indirect args. Right. Technically, we don't need any... Wait, can I do void? Didn't my compiler do that? Maybe it did. But anyway, we just want one thread here. And we just want to populate that, this guy simply with the so I want to use the number of leaf nodes. Number of leaf nodes divided by 32. It's a round up divide, isn't it? Yeah, because that's how many groups of 32 we need to launch for this guy. And then we need 1 on all the other ones. Dudes, what we're working on? We're working on an LOD cluster system for a bunch of spheres. So basically we've got this sort of 3D render of... We're trying to build all of our geometry out of spheres, and we want to go with super small spheres and see how, you know, try and push the limits as much as we can. So this is like the first sort of renderer that we wrote, just to sort of, you know, see what we could do. And now we're trying to build a proper LOD cluster system so we can have a very scalable solution, basically. This is all ray tracing spheres. That's the idea. But yeah, we're working on the LOD stuff. So we've got the first LOD tree of spheres, But we just need to simplify it now. And so we're working on that now. So this is 1, 1. So I need to launch this thing, and then... So does that compile? There has to be a type. Well, that sucks. Well, it doesn't really suck. It's pretty easy to deal with. You just make one, like, because at the end of the day, it pre-allocates 64 bytes of it anyway, because I've said that in the push constants. So there's not much difference doing it this way. What's it called? Indirect args. Alright. Ought to be good enough. So now we can launch one of these boys. This is going to populate the GPU arguments. So it's not indirect. We're just launching 111. Technically it's a null, but this is also fine. No BC. Not doing anything. Do we need synchronization? Yes, we do. We want to make sure that we're running after... We want there to be synchronization. For the last one of these guys. So we're gonna synchronize. We'll do a read write on the nodes one, right? And then the previous one will do a read. So ends up making sense. But does it blend? Maybe. No, I don't think we can blend. No. We might be able to do some interesting effects. There'll be no blending of the spheres, unfortunately. You'll be able to do some, like, yeah. Now, those are some old videos. You know, so, smells like 4G smoke. Good times. Or whatever it is, 3G smoke, whatever it was back then. Hey there, Kappa, how you doing? Right, so that launches that. So we've just got to get it right. So we've done an indirect before. Alright, so let's check it with this guy. So we're going into the global buffer. Ah, I've already got it. Excellent. So we're going to reach into the global buffer. That's where the indirect args are. Then it's offset of globals. And then I've got to... It's this one here, right? Yeah, that one there. Constants. And away we go. Oh yeah. Right, so that should be it. And then the beautiful thing is we have to check this in RenderDoc. So I'm hoping these two shaders will run. They could also blow up the computer. So fingers crossed they don't. Did you see the one where they put the iPhone in? Oh yeah, that's one of the originals I saw. Yeah, they did so many. So that thing just... It's funny how like the iPhone sort of bounces and sort of the bottom bits chip off. and then you start to see the screen sort of just off a little bit, and then within a fraction of a second, the whole thing's just turned to dust. Like, it's kind of interesting. The blender, its power. Right, so the stream goes down, I'll be right back, but it shouldn't do. Right, here we go. Oh yeah, we're running. So, we're running the build occupation map, and apparently, that is pretty quick. That is dirt cheap. Why is it that quick? That's what we need to know. So, we go over to render doc, and we try and see this image. Because hopefully, right? Hopefully, it is super duper quick, and that would just be amazing, right? But, you know, maybe it's not. There's an indirect. 571, that seems... Yeah, times by 32, it sounds about right. I don't know, maybe. Yeah, 16,000. Yeah, that's right. That's the one. Just hop in here and find the bugger. No, 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 no. No, 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 no. What? I could have swore it's not finding my... Right, so it didn't even write to the texture. That's the way I'm gonna look at it. So it didn't even do this. So I'm gonna use our lovely printf statements and just figure it out. I bought one of those just because of the will it blend videos. Excellent. What blend? It was the blenders from Blendtec. That was it, wasn't it? Yeah, it's insane. Like if you cut up an iPhone like that, like imagine your vegetables. Like they'd just be diced in no time. So good. Hey there, Rosmusco. How you doing? Welcome, welcome. Right, so generating the occupation map. Do we reach here? It was a long time ago, so I've lost it since then. Excellent. Yeah, between the moves and stuff. Alright. So we don't reach here. Do we reach here? Yes, we do. So we're getting caught here where they're not equal to spheres count for some reason. How many bits do we have? Did we have 8-bit? Did we have 3 bits and then we... You see, I think we have 3 bits. Yeah. So I'm being proper, like... So the sphere count that we should be storing in maybe needs to be like +1. Sorry, take 1. I need to be properly careful about this though. Right. And then this needs to be like a +1. Right. You know, I gotta save all my bits. It probably doesn't matter if I use an extra bit, to be honest. Yeah, the problem with that is means you'll get an invalid. Yeah, I feel like this is just going to be because either I've got to check two things or I can just check one thing. Yeah, I'm just going to do the I'm just going to up the number of bits. Alright, that ought to be good enough, and that fixed our problem. So we only fill in stuff that have full number of spheres in a cluster. We might change that in the future and have less. Like, 7 might be good. We might find 6 is a good number. But for now, it's in a full set. So let's write the word yes in there. See how well we go. Alright, GPU crash. Alright, we should be back. So let's see if that's... we probably do like a -1 or something dumb like that. Right. Sweet. Get some music going. Let's get a bit of Stone Rebel back in there. Rightio. So, we've got to be careful now. Got to be careful because we're in some instantly. So, right, something I don't know about, right, is do we actually have a proper node location? The first thing we're going to do is just going to be like node D, and then we'll do like we'll say it's at this sort of coordinate, right? So we did that. Literally like this, right? Sweet. And then I just want to do a return. So I think this is going to mean that... Let's comment this out just in case. Yeah, we can start debugging from here. Let's just make sure. So we was doing this anyway, right? Like everything was stopping here, so we're only doing these 3 more lines. We're doing like 8 take this LOD take 1, right? Then we're doing the number of yeah. Doing some sort of bit shifting. So we just want to see this. We probably want to see some other information as well. I want to see cluster coordinate in Yeah, let's do this one actually. Cluster core.x, y, z. So this is going to be within the highest LOD, so within the 256 cubed area, right? So again, if the stream crashes, I'll be right back. You know the drill. It's the way things roll. Okay, so that's good. Well, I was expecting... it not to crash... Sorry. Yeah, I was expecting not to get the... I was expecting it not to stop. Let's actually print this out. So did we have the... Did we... Yes, this is all right, yeah. We should just be see tons of yeses everywhere. I see no yeses in the... But if I do this here, we'll see a bunch of yeses, right? Huh? What? What's gone on since the reboot then? Have we only seen them on like the first frame or something? Nah, I can't think so. So we dispatch this guy. We dispatch the indirect. Right, that child index shouldn't exist. Used. I've been used. Alright, let's put someone in here. I just want to print out probably this number. Should only see one of those show up. Right, we've seen yes to 0. Excellent. Why are we getting 0 spheres down right now? Like, why is there no leaf nodes? Like, it's here. Like, it's here. It's after It's actually running faster than it was before as well. It's a bit skeptical. Right, should we re-enable some of the printing? Like, let's see all the allocations that happen. We're only seeing one node get allocated, damn it. What has happened since the reboot? Did we get a bit of corrupt memory on the disk or something like that? 7 nodes, 7 times right, all here. Who? Could have swore I read the word sync in the terminal. Should have been safe. So we go down the tree. Should we do this one? How we traverse down the tree? We don't even traverse down the tree. They seem to be running for longer and longer. Let's do this generate thing. We could be getting a buffer overrun, maybe. Wait a minute, what is that? 255. That's skeptical. What's going on here? So we've got left bottom near, right? There's 8 over. Yeah, it's all pretty self-explanatory. So why then is we and it then shift it over? Seems to make all the sense. So why is the root node there, for example? We zero it here. Um, hmm. Like, I'm pretty sure before we rebooted, this was running just fine, right? Or these guys running just fine. We can remove these guys. We can stop them running and then just see like, because before I even plugged these two in. So a git diff and see what's changed today. Maybe something stand out. I think we should just turn on more of the print code. So we should be doing another LOD basically. And that's definitely skeptical there. Right, so we're doing this transition. This is should happen after. So we see it allocates and it doesn't bother running anymore. Like this one literally just stops there in the tracks. Is it that atomic issue again? Did the compiler not get... Like we had to fix this atomic thing in the compiler. Is it something to do with that? Is it something to literally do with these? Is it saying stop no children or no child at that location? Yeah, stop no child. But the other one's continuing. Or it's stopping here. Ah, we changed this one, wasn't it? Right, okay, I see what's going on now. I know the bug. No worries. Okay. So the bug is literally, we didn't change the invalid. This one here is an extra bit. So this invalid is now... Alright, let's move this down here to belong with these guys, because that's where it belongs. This should probably be called volume spheres array invalid. Okay, that would be better, wouldn't it? And we just do all those bits on. So 1 byte, 2 byte, 3 byte, 4 byte. We could put all the bits on. But then the count would... Yeah, we'll leave the count at 0. So that way, this just work way better. So you can just check the whole array. Okay. I'm happy with that change. That's a good improvement. How's the kid? Kid's doing great. He's starting to giggle now. So he's starting to be tiggly. And it's starting to be like a more happier baby now. So it's pretty cool. He's starting to sleep better as well. You can just like chuck him in bed and he's asleep within, 10 minutes of crying at most probably. Starting just to get things now. He's eating solids. So we got him on, well, solids, puree. But yeah, it's doing super great. It's awesome. Yeah, so so basically I take the early shift and my wife takes the night shift, and she gets woken up about 2 or 3 times. But yeah, we try and get her lay in basically. But yeah. So yeah, because she's off for maternity leave basically. Yeah. Alright, if stream goes down, I'll be right back, but it shouldn't go down. Let's go. Okay, so we're running. Still not seeing the numbers I want to see. GPU hprintf. I want to see yes. Oh yeah, we disabled these shaders. Duh. Let's comment that line out. Okay. So the stream does, we'll be right back. You know the drill. You know the drill. Alright. Oh yeah. It's going. So this though, they're all at 0. Okay. Amazing. I love this. So the problem is the cluster coordinate is always 0 for some reason. So shifting to the left. That's probably alright, isn't it? So we're not setting the lock. It should just work, man. We should re-enable the printing code for come on. This one. We want to see like if they're actually getting the proper location information. Right. Looking kind of cool. I expect them to be probably bigger at this point, more than 10 at least, right? How many? I don't know, man. It's hard to tell based on the LOD. Even the LOD is set to 0 still. Oh, what? Doesn't make any sense. Something is super fishy about this. $24. Maths. Maths me. That's probably the problem in it. So anyway, that was just to do the LOD, nothing. Right. So LOD 3, you get 1 shift left. 3, right? So that's 8. So that seems pretty good. Although, are we already painting up to LOD 3? I thought we targeted 7. But I guess the buffer over... Yeah, we got buffer overflow. Yeah, so technically there's way more nodes than this. But we ran out of print buffer. That's it. Okay, that's fine. So okay, so where's my printing at? Let's turn that off. So in this shader we're doing the occupation map. This is printing out some coordinate. As we know that information is being set there, but I think the LOD wasn't being set initially. So that was end up being 0, so it basically buggered the thing up. So I think that is the problem. So if it crashes, I'll be right back, but it should be right. So still some problems, it's still not working, so we'll figure out why. So what is... Oh, position divided by this? What's up with the divide, man? Why is there a divide in there? That's just copy-paste error, surely? So it's the position. Oh, I've got to be really careful here. This is the cluster position. So is it... Oh no, it was right actually. This was meant to be 2. We should have volume dim. That's what I need to have. Whoops. Whoopsie. Just really understand the constants. Right. So this is saying divided by 2. Why divided by 2? It might need to be multiplied by 2. And that's your sphere position. Let's try that. Right, these numbers are looking alright. No, they're looking crazy. Bit too much. But yeah, at least we get numbers. Numbers are good. But we need correct numbers. So is it a divide? So your location within the cluster of that LOD. Maybe it is a divide. Let's put that back. See what we get. Right, the biggest number we should get is 256. So something super fishy is going on. So we're gonna do something like this. Okay, so the number we're actually getting the highest LOD is already like 2.5 in that sort of range anyway. That's fishy. Like, why are they so big? I could have sworn when we used in the other printing information it was it didn't have this issue. So maybe we're indexing and grabbing the wrong node and we're getting invalid data. Which we can don't know why it's crashing. So this looks sensible to me. There's sort of these numbers. Let's do something like hey, if the LOD is 7, right? So we only see the top, the highest LOD. But these should go up to 1228. Oh, I don't see anything, eh? Interesting. Hmm. We already literally only seen up to LOD 3. Have we not got enough room? No, got enough room in our bits. Pretty sure. Right, definitely something fishy going on with the storage of this still. So your 4 bits, that should give you 16, space of 16, right? Uh, um, yeah, the numbers seem alright. 1 byte, 2 byte, 3 byte, 4 byte, and 24 seems good to me. So what is it? Can I see? Can I see something where we do some form of traversal like this? I don't see any of that either. But they're kind of running to construct, like they're taking time. So I feel like they're getting the wrong LOD number in the like you're getting the current one and you're adding one. Like what's the problem with that? So I guess you want to just say, let's just print out the alloc code. Alloc at this LOD. So it's that sort of like volume plus the location. LOD node location plus 1. So what do we kind of get at the end? Kind of overflowing a bit. But we're getting LOD4 here. Why am I seeing all the other stuff as well? I didn't really want to see that. We're seeing at LOD3, blah, 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 blah. So maybe with the way we're traversing down the tree is like we're sort of just hitting the So we should probably follow a single thread and just see how it works, right? So let's just follow the furthest left thread, right? So that's just literally dispatch index 0. And then like this will just tell us like how is it actually behaving. So we want to go, okay, if dispatch index equals 0, we can like literally follow how this one gets all the way down to the bottom. So let's just start there. what happens to this thread? Bear in mind, we're probably going to want to remove the other print statement down here, which just keeps track of the allocation. But let's just see how it behaves, right? I don't think this is going to be that great, though. Okay, so this one literally only goes down a few places, then it stops. Can we move the edit so it's in the lower left space where 0 is going to go all the way down? Can I do that? Would be good. So that's in the lower left of the whole volume. No, I'm not seeing anything. Right, it's 32 big. Yeah, that's problematic. The size of that thing is problematic still. Definitely a problem. But yeah, I probably need the alloc thing back, actually. Let's put that back. But I only really want to put that one with this sort of thing in it as well, you know. Right, so we clearly see the separation here. So we're going down, alloc 1, and then it allocates another 1, right? That's not good. So maybe it is going down the number of layers fine. I think there's a bit of a problem with the way we're doing our ellipse verse box check. I think it's not good. Hey there, Perry. How's it going? Happy New Year to you, sir. Hey, the new moderator. How you doing? So LOD 1, 2. Like why has it been repeated? Because when you alloc a node, right, I know what's going on. Do I? Maybe. Where is node even? Right, so that looks like invalidated to me. But then, why is it on the next one? The invalidated does look skeptical, but why? So we're gonna read the LOD into here as well. In that traversal code, you know. Right here. We'll do a node at this LOD. Oh, I know what's going on, damn it. I know the problem. That needs to go here. We need to read the node in. We didn't read the node in the whole time. Surely that's problematic for something. Right, for generating the location. Right. Okay, at the end. Okay, I see the problem. Read the full node in there. Yeah, so we ran it too many times. Nah, that's just enough. Excellent. Okay, there's the problem. Now, right, what else do I want to look at? I added this thing in here, didn't I? Let's get rid of that. Okay, so that's going to generate a proper set of... there you go. So LOD 1... Then it allocates LOD 1, 2, 3, 4, 5, 6, and 7. Voila. So now all the positions will be set correctly as well. So hopefully... Happy New Year, good, thanks, how are you? Yeah, man, doing good. Keeping busy. Yeah, just enjoying time with the family. Lots of working and preparing for my holiday in February. We're going to go to Australia. We're going to go down under, Perry. Going to fly down under. Alright. So now we can go back into this occupation map. That we're generating and just look at the numbers, right? So the node locations. Right, these are looking like we're getting numbers now. This is good. They should be from 0 to 128, but we're in the lower left-hand side, which means like this seems like a lower sort of number, right? Like, where 128 is the highest number for the cluster locations at the highest level of detail. So 64 is halfway. So if we've only put it in the lower left-hand side, 20 seems ideal, right? So that's looking good. So now let's transition it from a cluster interesting. I think we could be off here. We might be allocating too much memory. The number that we want to go to is the number that we want is volume dim divided by 2. We want 256 divided by 2, right? Because that's the number of clusters. Oh no, this is a bit set. Yeah, it's a bit set, isn't it? Yeah, this is going to be way off as well. So I need right, and then I get 2 clusters. I get 2 by 2 by 2. Is that right? I get 2 clusters across every dimension in a single. Yeah, so it's 2 by 2 by 2. So it might be divided by 2. So I mean, maybe I want a new constant to make that a little bit more readable, you know? Maybe I want a constant like volume. Volume cluster dim. Number of clusters in a volume, something like that. Along an axis. Still thinking you're mad doing a little one. Yeah, I know, right? But it's getting much better. Like, the past couple of weeks has been really good at being a lot calmer and everything. So it's pretty good, and it's kind of getting the knack of sleeping. No, they're just coming out of summertime, so it's going to actually be the 28 to 30 degrees. So it's going to be like, nice weather. Well, for me, like, I like a 20, 24 degrees because otherwise I can't like move around. It's getting way too hot. But obviously my wife likes much warmer. Sure. Because she comes from Zimbabwe, so it's like her natural, sort of climate, weather. Um, yeah, Feb is the best time. I was there all of Feb in 2018. It ranged from 25 to 4 degrees. Oh, wow. Oops. Yeah, crazy. I've never been. It's going to be interesting. We go full tourist mode with my camera, hat, socks and sandals. I'm joking. No socks, sandals. Um, uh, yeah, there's multiply in it. Multiply. So you want numbers ranging from like 0 to 255 inclusively. Right, and considering you're only doing the lower left hand side, this 50 odd number seems good enough. Yes, I think we're getting good numbers now. But yeah, okay, I think this is interesting because ooh, ooh. Right. Divided by 2 because we're getting 2 bits. We're getting 2 clusters. It's a bit set. We're getting a 2 by 2 by 2 of clusters per. Okay. So you want to go to the highest LOD, but I think you want to take away an extra 1 because you're not getting. You don't want to get the number of spheres. You want to get the number of. Yeah, no. You just don't multiply it. Because I don't want the number of sphere. I don't want a coordinate of spheres, I want a cluster coordinate. Yeah. So that'll work even better. Okay, so I think we're getting the right things now. When we re-enable the other code though, it's probably gonna, I don't know if it's gonna crash, but yeah, we're in these 20 ranges. That seems sensible. We might want to do a +1. Because you need extra for a border or something dumb like that. But yeah, so the number of, so how much memory is this? Well, it's 128 divided by 2. Then it's cubed, right? Well, I'm doing 65. Let's just do cubed. So it's that times size of int. Right, it's about a meg. A little over a megabyte of memory. Yeah, it's not bad, right? Just don't make the mistake I did. Landing back in Heathrow in shorts and a t-shirt. Yeah, I bet you're thinking like, oh, it's March now. What's be good enough? Shorts and t-shirt. No. Yeah. Needs to bring. Probably need to bring a coat. Probably go out wearing the coat, and then bring a hoodie. That's it. And then yeah, I think that'd be ideal, wouldn't it? Get 3 layers. Yeah, it didn't help. I came back when it was the Beast from the East cold thing. Okay. Not sure if I remember that, to be fair. But yeah, just oh, okay. But it's standard February, right? In the UK, where you would get like, for some reason in February, it just gets so cold sometimes. Yeah, and it's not been that cold in December or January. Yeah, it happens like that. It's kind of interesting the winter in the UK. Sometimes it could be like 10 degrees, and then all of a sudden the next day it's just like 0. You're like, what's going on? Because we're in like, yeah, the weather varies a lot. Okay, so the computer is probably gonna blow up. Oh wait, we want to print one more thing. So like, what is this number? Basically, right? I think we want to do that. I think so. If yours goes at 12 degrees during the day now, so exactly, yeah, it's happening right now. It's got a bunch of zeros. Doesn't look right. Because if I want it to be 0, just put the word, I just put a 0 constant there, right? So, hmm. So where were you using these guys? All right. So I would have not even done a for loop. Excellent. So this one is like, yeah, I know this one is fine because I've been using ones which are derived from this, right? Did I? What is going on? Two seconds. Let's just say this is equal to 2. Something we can easily tell what the value is. See anything? What is going on? Oh, it's a leaf sphere. Got it. Right. I just realized. We've only got one edit. And the edit thing is pointing at LOD 7, which is the highest LOD. So obviously when we have these conversions which convert it to the highest LOD, they're going to be 0. Right, it just makes sense. So this one, cluster LOD's highest LOD is 0. That makes sense. Highest LOD clusters count. What are you talking about? Why is it this thing? So you need to get a number where you're saying, for this LOD, this is the number. Yeah, the highest LOD cluster count is just a constant. Right, it's volume. Right, why are we going over all of the... No. How many LODs? Okay. I got it now. At this LOD, how many clusters are we writing into the bit set? So this would be, would it just be +1? So if you're at the LOD, if you're at the highest LOD, it's just 1. If you're at the, if you're 1 off of it, it's 2. Right, it might be 1 shift left. If you're 2 off of it, it's 4. Right. Yeah, then 8. I think that's right. So that's the reason why we're seeing 0. Okay, so now everything's in position. Will it will it will it crash the GPU? Maybe. So if the GPU crashes, I'll be right back. You know the drill. Yeah. Okay, we're still running. And it's taking actual time now. It's not massive amounts of time, right? But it's taking time. So we should be able to bring up render doc. I'll go PAL, render doc, and we should be able to inspect the texture and see 3D slices, sorry, 2D slices of the 3D texture bit set, and see where the fully occupied clusters of 2x2x2 spheres are, right? So you've got a 2x2x2 of spheres, and that's a cluster, and we'll have a bit for each cluster. And so we should be able to see in the texture. Here's the indirect. Oh, can you see it? Here it is, guys. It's working. Clusters. So this means then, so I think we have to zero the that's something I kind of just jumped to this thing not thinking what I have to do. So you're only writing, so we need to zero the whole thing. How am I going to do that? How am I going to do that? Do I do a shader or do I do a special, do I do a sort of like special thing? Zoom. Wait a minute. Do you got like a command image? Because there's like command buffer. What is it? It's like fill buffer. Right, clear image color. Okay, so we could just do a shader. It's probably just as quick, but it's, you know, this could technically be or more optimized on some hardware or whatever. So you can say clear color image. Or just say clear image to a clear value. Right. And you can clear a whole bunch of them or whatever. Or we could just write a custom shader and just clear it. Right. Yeah, but I just need to get another drink, and then we'll clear some texture, and then we'll reposition this sphere we're painting down and sort of see it within the texture. So remember, this is not, you're not seeing the spheres, you're seeing the clusters, which are 2x2 of spheres. But yeah, anyways, BRB. Alright, welcome back everybody. So yeah, maybe we should do a quick clear image thing, because I've done it for the buffer one, right? Let's add a new thing to the GPU abstraction. It should be like proper easy to do it. So I've got like a mem set one, I've got like a 0, 1. So what we wanted to do is basically say texture fill. Well, I could have called it buffer fill. Like we just want to use 32. But then it's kind of like, let's see what the thing does. Right, let's read the documentation on this one. Does it? It's based on the pixel, isn't it? Yeah, so maybe just do it based on the format, isn't it? Yeah, we based on the format. So I think we'll say, we'll call it like clear. GPU texture clear value. We want a union. Union. We'll just copy the Vulkan one, right? That's what all the others will probably do anyway, something like this. Good old synth. Yeah. So when I say texture clear, we pass in the clear value, and away we go. So we want a texture ID. So we're just going to go ahead and go into the GPU implementation. It's basically like this one. So let's just copy the internals. So the idea is that we obviously want to verify that it is a texture, not buffer. So we add some synchronization. What is this? Yeah, so we put a barrier down. If there has been any resources synced on. Is that what it's doing? Yeah, if it has any resources that need synchronized, that's it. Yeah. So we say, hey, synchronize on this texture, and then we say, because we're writing to it, and then if there needs to be, if it's been previously written to or something like that, then put a barrier down. Now, this one here is checking to make sure that it is a texture type. So I don't know if we have. We must have that. We must have that. So there is this one, and I think we just do a. Make sure it's not equal to buffer. There we go. Texture ID must be a texture. Now we're just clearing the whole thing, but you could do clear a sub region of it, but we don't we don't want that right now, so we're just going to keep it as clearing the whole thing. So then we call into the back end, then we say, hey, we've got this texture here, I want to clear it. Then the back end, aka Vulkan, would do that. This one here is setting up the, it's going over and all the synchronization state and sort of making the after access mode the before access mode, and then clearing the after access mode. That's how the synchronization code works. So we now just need to make this new backend guy. So inside the backend, GPU backend.h. We need to make effectively something like this. Aha. So this would be texture. So in the backend now, so we'll just go to GPU Vulkan, and we're going to go ahead and put. Okay, so in here, we've got some. Let's just copy this one again, and we'll fill it in. So we get our active frame, fish out the command buffer, because you basically flip between. You swap between a command buffer every frame. So one frame, the command buffer is being read from the GPU, then while the CPU is writing to the other frame buffer. So we're sort of paddling between those guys. If we're profiling, we drop in a timestamp before, right? And then we drop in a little timestamp, and then we do the operation. So this would be, I'll go to here, and this is the custom function loader we have. It's pretty simple. Just loads function pointers auto magically. I wonder if there's a clear image too. But no, we probably won't need it anyway. So now we have the function pointer loaded into that data structure, so we access it. Call the function pointer, pass in the command buffer. Let's check what the bells and whistles are. We need an image. So backend, get the backend resource from the front end resource. We want the image. Then we want the image layout. So we should have been transitioned into, is it transfer? Transfer destination optimal. So, oh wait, or it can be in general. We're already in general anyway at this point. Yeah, that's good. So we don't need to do any transitioning. But we do need to tell what it's in. So the sync code would, because it's being written to, the sync code would have already transitioned it into the image layout general. So we don't have to worry about transitioning it using pipeline barriers. Now the color is just a straight ABI compatible thing. But it's the same thing really. We could technically just copy it and put it on the stack. That would probably be better. So I'm just gonna do that. VK value, we'll call it. And we'll just do VK value dot E32 0 equal the value. Well, I can just do that actually. It's probably good. value given 32, 0. 1, 2, 3. And that way, say if we did change the ABO of this, it wouldn't mess up the back end and will be like, it could be a bit weird to find, basically, right? And I'm sure the compiler might be able to, it might have an optimization for it, but at the end of the day, it doesn't matter. It's so negligible. So you have to have a sub-resource range, which is fine. So we'll fill in one of these boys. Oh, so you clear the whole texture. Right, fair play. There's no sub. Right, sub-resource, not sub-area. So if this is the VK sub-resource range. And so the access mask is color, right? Right, it's gonna be easy peasy. Right, so you only clear an array. Wait, you can clear many layers. Okay, so we'll just clear the whole damn thing. VK aspect color. So the thing is about textures or textures in Vulkan is they can actually have different. A texture can be multiple textures, right? You can have different. You can have a say if it's a color with a bit of depth in it. The driver can do whatever it wants. It could maybe, I guess it could pack those together if it wanted to, but I think mostly what they do is, like, if you're referring to a pixel and it's got a color value and a depth value, you need to say like which one of those you want to be referring to. So you can actually say refer to the depth value here, or something like that. There's more complicated ones which I don't fully understand. Don't understand the others, to be fair. But what the hardware is probably going to do is it will have two textures, one for a color, one for a depth. But I guess it could pack it as well. So maybe it does both. But this has to be color because we're using the clear color image. The spec would say that. Blah blah blah. There you go. They must only include color bit. Right, it just makes sense. So the base MIP is 1, and then we'll just use all the MIPs. So we'll just clear all the MIPs. Yeah, it's something we could change in future. Really not fussed right now. Texture. Texture what? Wait a minute. Oh, yeah, texture. There it is. Fantastic. So we'll just throw that in there. Just the last one. Address of VK sub-resource range, and then away we go. So it's kind of at the same time it took to write a shader. So, and this should work across more things. We need a number of sub-resources. There we go. So now this will be able to be plugged in and we can clear the texture. And obviously the final thing is the timestamp. So there's two timestamps which go down, one before and one after. And then we take the difference, and that's how we do this lovely profile information here. Or we tell how long something took. So let's go ahead and get this thing plugged in. So what is it that we're plugging in? Well, before we do the occupation thing here, we want to run a shader. Sorry, I want to run that command texture clear, which probably runs a shader, to be fair, on some hardware, right? But maybe there's some special hardware in it, you never know. What am I doing? I'm clearing the full occupation map. And what else again? Oh yeah, what's the clear valley? Amazing. Value, and then we'll just simply just do value. I guess we'll just do this, right? We could have just used a vector 4. Wait, I've got those things, man. Why not using that? Why did I do an array like the GPU driver did? This would be way better, right? I got these vectors, man. Why not using them? So in the back end, it wouldn't like that change, so we'll just quickly go into there and change that. So dot x y z w w, yeah. Cool. Right, so we're saying U32 times 4. Now we just want to do 0. But equally I could have just zeroed the whole thing. What we want to do is use this way to do it. And then away we go. So now with that texture clear, we're going to get rid of this undefined image now. It's all going to be cleared properly. And something that we should do is we should move the thing into the middle. So we move it to 128. This means that we should see the sphere in the middle, basically. And remember, this is viewing clusters that are full filled with spheres. That's what this occupation map is. Okay, so the stream goes down. I'll be right back, but it should be running just fine. Okay, so we're doing a whole clear now. The clear, that's not so bad. I'm happy with that number. So now we want to boot up. Yeah, I'm just thinking, we can't do a clear in place because we're not doing. Yeah, we can't do a clear in place. We need to do a full clear where it needs to happen. So let's do another capture. Kabam. Where's the bugger? The indirect right here. Here's the clear, right? And I don't see anything. So it's because I moved it. It's probably something to do with the ellipse not being either way. Yeah, I gotta do an ellipse verse what's the word? Ellipse verse ABB. I've got to get that code to work. Alright. Oh yeah, so we're seeing it here, you see? And now we're not seeing any of the clear stuff. So let's change it to a box. And put it in the middle, and then we can fix the ellipse versus ABB thing. Here's the keyboard. Hey Cat Payne, how's it going? Just got to stream, was helping my buddy move. Awesome. What a nice person. Decent stream today. Has it been a little challenging? Yes, we've managed to launch all the shaders to build the full tree, but just the leaf spheres. So not building any lower level detail, right? So we're building the full tree from one single brush. Edit right now. And then we're building an occupation map. The cluster occupation map, where there's a bit. Each bit represents, each bit represents a cluster that's filled with spheres. And it's a bit set basically. So we can easily check the neighbors and be like, am I fully surrounded by other clusters? Yes, I am. Then I need a lower level detail, basically. But yeah. How did the move go? Did you get it all done? Right, so hopefully it doesn't crash. Okay. Good. So we rerun that. We'll still see a circle even though using a cuboid to paint it down, right? Because, wait, will we? No, we should be seeing cube. We'll see like a cube. Oh, what is going on here? I'm not seeing anything. No. Okay. There's something to do with the collision code or... Wait, let's make it a bit bigger. It's way too big. Right on, just you're almost done, just some furniture. He's well done, me buddy, so it was nice to see him before he's off. Oh. Just is he moving away far? Where's the map? Okay, so now we just need to debug the whole sort of node situation. Like, we should be seeing... So after this occupation map, we've got to do a specialized downsampler, which was pretty fun to write. Then we've got to refine the LOD tree, build the lower LODs, and get rid of nodes that don't need to exist anymore. Then we need to reset the volume, and then copy it into a more persistent place in memory. So still a bit to go, but I reckon things are looking good. But so we just got to debug why this doesn't. So we got to let's just print what nodes get allocated. Right, clearly a hell load of nodes get allocated. So yeah, but the way the sync code works, it have a sync between everything anyway because we're debugging. We're measuring performance. So. Okay, so we're allocating a whole load of stuff. So let's see, are we seeing anything like this? Right, we're getting numbers. So we should be going in there and writing some stuff out. He's moving to Georgia. Do some contract work. Overseas deployments, thankfully, lol, he's civilian now. Oh, cool. Not bad. You think the rad debugger would be good for you? Yeah, it's just a general debugger on an executable format, right? So it's not necessarily joined to C and C++. but it might have some special features for it. But yeah, I'm definitely interested in checking it out. Um, I don't use Windows, but when they do a Linux port, it's gonna be really great actually because we currently use GDB, but I haven't bothered to learn GDB because it's CLI tool and it's just one of those things, right? Um, so I know like basics of GDB, but I'm not like an absolute wizard at it. Um, it would be good to have a competitor to that, basically. Um, but yeah, at work I use Windows, so um, maybe it might be useful there. I'm not sure, but we just use Visual Studio, right? So yeah, user-friendly competitor, exactly. Ooh, so it seems like we're writing these buggers out. There's a Vim GDB front-end term debug. Haven't used it much, but it's interesting for simpler cases. Yeah, I think I've tried to get a few of these up and running. I don't know how. It's been years ago before NeoVim was a thing, right? Put it that way. I've tried to get some of those things up and running, but I never could quite understand it. Uh, well, thank you so much, Kat. Appreciate it, sir. Right, so we are putting one in there. Seems legit. We're doing stuff, man. Like what? We're putting bits in there. Bits be packing. Unless it's something to do with this code here. But it's perfect, I swear. Uh, the bit might be... Well, we can tell, right? Like, what is that? So we're seeing like non-zero values, right? So they're definitely going in the texture, right? They could be out of bounds, but I don't know. Yeah, I could have swore this would have picked it up. Right, let's do another capture just in case. And 500 megabyte capture, lovely. Um, Probably just dumping GP memory to disk. Alright, this is our boy. This should be pixel rights, though, right here. Come on. There's no pixel rights here. But those numbers are within a decent range. They're within 128. 0 to 128. So, I guess the other thing is like, just check that this coordinate that we write, because we've checked the bit, right? So let's just check the coordinate. Turns out it comes bundled with the Vim. Oh, right. I didn't realize it comes bundled with Vim. Ah. Actually, now you say it, I think I've heard about that in the past. Right, it might have been taken out of Neovim. One of those Gen Z boys. Neovim. Here we go. Oh, big T. Right, okay. Right. What a downgrade. Right, so we're seeing clearly integers within the range that fits in the bits. I think it's 64 wide. Let's take a look at this texture. Can I go to the image? Yeah, the 65. Isn't there meant to be some pipeline? Do I not see? Oh, yeah, there's a pipeline barrier. Transitions into the right state. There's an image barrier there on the... Wait a second. There we go, on the occupation map. Transitions it. Going from write only to read, basically. Storage, right. Well, the access mode is a little bit wrong. Not gonna lie. It's a little bit wrong. Yeah, technically it's a little bit wrong using this. Am I gonna work on some hardware probably? Right, let's remove the clear and just see if it fixes the problem that we're seeing. Right, because I feel like the texture could be... Oh, no. Yeah, something's up. No, it's up. So remove the clear now. What am I looking at? Texture. They're all buffers apparently, it's wrong. It doesn't read the... Right, let's rerun that, I'm not sure what happened. I didn't trust that one, it should have showed 2 captures, I didn't do 2 captures. Right, why is there a 2 indirects? Of 141, what shade is that? Calculate sphere counts. Tile binning. Right, maybe I was looking at the wrong texture the whole time. Because I was looking at the wrong... Damn it. Yeah, no. Maybe I was looking at the right one, but we should see something here if it was rendering to it. Let's go back to one of these edit things. Let's put it back at 0. It could be the fixed point thing. No. clear. Right, there we go. We're seeing the block here now, right? Um, yeah, something fishy. So we put a cuboid down of right, and these are clusters. And not each pixel, each bit within the pixel represents a. If we go to the edge, we might see. Okay, maybe it's perfect. But yeah, might not look fully red, for instance, for those places. But yeah, so I guess if we move it, let's move it half to the right or something and see how this behaves. It could be that it's going the wrong way, right? So let's say, oh, wait a minute. This is a 3D texture, right? So if we put it in the middle by 128, what are we going to see? We're not going to see anything at the first slice. It's going to be in the other slices. That's the answer. So I'm confident to rerun that now. And I'm confident to actually change that back to probably an ellipse. Right, this is it. Running slowly because the amount of printing was doing. Alright, so you won't see anything here, but we've got a slices, right? Alright, we're seeing something. Zoom. And it cuts out and dies. So something very skeptical is going on. With first of all, we're only going like this half of it or whatever. That might be to do with the like we change it back to a box. I think that's something to do with the collision code we've got, which we can fix. Let's rerun that. Here we go. Okay. So we slide through the faces. It'll just appear all of a sudden. Okay, so this one's still a bit messed as well. And then it stopped. Same sort of problem. Interesting. Yeah, see how this corner pixel, these ones are not fully occupied, they're partially occupied. Are they partially occupied? There's no bits that are on, is there? Yeah, they're all zero. There's the value down there, the zero. Yeah, I don't know why these guys are not occupied at all in any way. I'm not sure. What that is exactly. Because we're 128 in the middle. 64. 64 being half of one of these. That's half dims. So it should be going the other way. Yeah, something's up with the something's up with the with this code here, where we're doing the intersection checks. So we should probably analyze those and make sure these are robust. That'd be ideal. Right, so after we've done this problem here, the next thing we'll need to do is get this downsampler, get this shader fully working, make sure it's all good, which is the occupation map, this thing that we're building here. Then after that, we'll probably get the downsampler working as well. So this would be in the next stream, basically those three things. That should be manageable. So we're going to do a full MIP chain going up to, just going down to 1 pixel basically, I think. Or maybe 2 by 2 by 2. Something like that, like a full MIP chain. and well, maybe not full merge node, but nearly. And then this means that we'll be able to just do a couple of samples and check all the neighbors in like a very easy check like this. In the shader where we do the refinement and figure out whether or not we to keep this level of detail because it's just way too much. Something like that. Right. So that should be it. I'll upload the current code to the GitLab for those who are supporting the stream. Thank you so much. Everybody who's a subscriber and Ko-Fi supporter. So let's find somebody to raid. So our next be on Tuesday, 6:30 p.m. GMT, Thursday as well. So wait, what? Maybe 7:30 p.m. actually. You know, change my times. But yeah, there's a Discord channel. There's a. If you check out the about page on the channel, you see it all there. Reverse engineering VM instructions. This sounds like the thing we should read. Thank you so much there, Jal, Toast and Kept Payne. Appreciate it. You guys have a good night too, and have a good start to your week. Yeah, have a good start to the work week, you know. Rightio, catch you later. See you later, Glorista. Appreciate it. Right, a bit, guys. Much love.